Hello everyone, Code Purpose here. We are going on with the 30 exercise in this series of tutorials, which is another milestone on this series of tutorials. This exercise name is fit squares in triangles. So we need to fit squares with dimension 2x2 in a right angled isosceles triangle with the base B, where the base is the shortest side and the one side of the square should be parallel with the base of the triangle. So we have t test cases, and we have in each test case we have given the length of the base. So using this, we need to find how many triangles we need to fit, how many squares we need to fit in that triangle. This needs an geometric explanation. Even if I'm not a person that likes geometry, I'll try to explain it as good as I can. And firstly, let's explain the term right isosceles triangle. It's a right angle triangle where two sides are the same, have the same length. So firstly, if we see carefully, if the length of the base is less than the required square, for example, if it is 1, we can fit a square there. Even if it's a triangle with 2 and 2 dimensions, we can fit there nothing, because we have only just the half of that square. So firstly, what we need to do is get rid of this size. We can fit here a triangle. Let's say this is a 2 by 2. Here we can fit again nothing. We just get rid of those, and after that, in the leftover we are going to try to put as many squares as we can, because it has both sides are the same length. That's a pretty good thing. So if we have a length of 9, the other one would be 9 too. So if we get rid of 9 with minus 2, then we have a leftover of 7, and in this leftover we can put only 3 squares. This down here is the base, so it has a parallel one with the base. Also it goes up the same way. Here we can put only one triangle. So in the upper corner we have 1, we have 2, we have 3. So this is a arithmetical progression: 1, 2, 3. And to calculate this sum, we have a pretty beautiful formula discovered by Gauss, and that's n multiplied by n plus 1 over 2, where n is the last number on that progression. So 1 plus 2 plus 3 is equal to 3 multiplied by 4 over 2, which is 6. And as we saw here, we have 6 triangles. And how we are going to know the last member of this arithmetic progression? So we are going to know this number of the arithmetic progression. At the beginning, as we said, we have the base. From the base we get 2. If we had there a bigger number, 3, 4, 5, which if we had three triangles, then we going to subtract minus 3. And Okay, after that, to this, we are going to get divided by 2, and that's the number of squares we can fit maximally in a line. So 9 minus 2 was 7, divided by 2 is 3. That's how we get our n here. So let's go and convert this to the in code. So firstly, we had number of, okay, can't write here, so I guess I go right directly on the CodeChef editor. So we declare the number of test cases and the base. We read the number of test cases. We make our famous for, which iterates t times for each test case once. We read the base length, and we get a helping variable, which is most squares, let's say, and we got the formula that is by b minus 2 over 2, and we need to use the Gauss formula to find the sum from 1 to this most squares, which was most squares multiplied by most squares plus 1 dividing by 2, and after this we output a new line. So let's go take the input, copy, run it with a custom input, run, and 001133661010. Yeah, that's the correct answer for this test case. Let's see if the other test cases would be solved correctly. Yeah, that's solved correctly also. We came to the end of the 30th exercise of this series of tutorials. Thanks for watching. Don't forget to subscribe by clicking the red button right below the like button. Also turn on notification by clicking the notification bell to not miss the upcoming videos. See you soon on Code Purpose.